Hey guys, I'm just going to explain to you today how to make error bars for your data and run a couple statistical tests that you'll need. Primarily, most of you will need the two statistical tests I'll go over to analyze your data. So first off, when you get your data, if you're looking at a bunch of trials, maybe even just 3 trials, anything from 3 to 1,000,000, what you really should graph is not each individual trial, but an average of the trials. And then what you want to do is let people know the range statistically that the data could be in. So let's take a look at this. So if I have my data in Excel, I want to set it up in these vertical columns like this. So you see I have 3 here. This is from an old project that somebody did where they tested to see if these additions to a helmet could decrease the amount of force that made it through from like a blow to the head. So he put Kevlar in. He has a standard helmet, no helmet, and one with Kevlar inside. So the first thing I want to do is I want to calculate those averages. So what I'll do is below my last trial, I'll write in the word average. All right, and I like to bold it out. Below that, we're going to calculate something called the standard deviation. You guys probably have used it at some point. And the last thing we're going to calculate is the standard error. Yes, Riley, May 4th, you may heat up your pasta. All right, so when I get into here, what we're going to do is now calculate the average of each column. It's pretty easy. If you go up to the top, there's something called formulas, and those are things in Excel that it uses to calculate different mathematical quantities. And you can see there's a bunch. There's a bunch of different formulas up here. For average, it's a really easy one to get to. You just go to this one called auto sum, and you click average. It should actually select all the numbers just in that trial. If for some reason it doesn't, you can just click and drag until you have it selected, and you just hit the enter key and it calculates the average for you. It's really easy to do. You can do that for the other 2 columns, or there's a little shortcut. If you take where your cursor is here and you see how it's like that fat white cross down in the corner when it turns to the skinny black one, all right, that will take it. If you click and drag, it will copy the formula to the next 2 columns and give you those averages. So now we have 3 averages. When we graph, we want to graph those averages as our bars. But now we need to calculate what our standard error is going to be so we know the range that the data statistically is in. So now I'm going to calculate the standard deviation. Again, I can go up to formulas. I'm already in the tab, and I'm going to go to more functions and statistical. So formulas, more functions, statistical. I'm going to go down until I see this one, STDEV.S, standard deviation of a sample. This P1 is just for population, but we're doing a sample. We don't have the entire population usually. So you just click that, all right, and then this guy comes up. Don't worry about number 2, you just need number 1. You're going to click the little arrow. When you click that, you come over and you select the data from that column. Do not include the average. And then you hit enter. And then you click OK. And you've got your standard deviation. Great. You could do that again for the next 2 columns, or use that same click and drag the bottom corner, and it pulls it over there. Finally, standard error. So what standard error is standard error gives you some better accuracy for having more trials. So in this case, there were 15 trials. You may have had 3. You may have had, who knows how many you had. So in order to get that, Excel doesn't have a formula for that, so you got to teach it, right? So you hit the formula for that is the standard deviation divided by the square root of the number of trials you had. So you tell Excel that you're going to do a formula by hitting the equals button. All right. Now we want to take our standard deviation, which we already calculated. So you just click this cell right here, the cell above it. Where the standard deviation was, divided by, so the slash, the square root, so that is in formulas. It's under math and trig. Come down here, or you could just type it in, which is SQRT. and the number you put into this one is 15 just for this sample. Yours may be 3, yours may be 5, depends on how many trials you ran, and you click OK. And there we go. And you see how that number is a lot lower? It's because we divided by the square root of 15, the number of trials. So the more trials you do, the more accurate your information is because you've done it more. So again, now you click the bottom corner and drag over, and we've got our standard error. These are all the things that you need to calculate. Usually I bold them and I highlight them so I know not to change them. So there you go. All right, so now how do we translate that into a graph? So you go, for the most part, when you're doing data like this, your graph will be a bar graph. So you can go insert, column chart, all right? But before we do, let's select what we want to graph. We want to graph these names. I'm going to hold down Control on my keyboard and select the averages because I only want the bars to be the averages. Now I go to Insert. I click on the column chart and the first column chart up here. And as you can see, it makes a really nice graph for me. Things I can do after are add in axis titles. So this would be, the bottom axis would be helmet or, helmet type. And on this side, this would be force measured. And always put units in there if something is measured with units. And you can make your own title, all that kind of stuff. But how do I get those error bars in? Well, it's pretty easy. On Excel, when you get this graph, you're going to click this little plus button for chart elements. If that plus button doesn't appear, you can get to it by clicking on chart design, add chart element. So, but usually that plus button's there. Sometimes it goes away. It's really weird. So there isn't error bars here, but that's error bars Excel makes just based off of the number, not based off of the actual data. So you have to tell it. So we're going to click the little arrow next to error bars, and we're going to click more options. Do not get tempted to use the standard error. Again, it's not actually using your data. So you click more options, and you see these guys over here. If this isn't already clicked, click error bar options, the graph looking one. And we go down here, the error amount's going to be custom. And then you click specify value. So this standard error is how much the bar should go up and how much the bar should go down. So we're going to go to positive error value, and we're just going to click and drag. Then we're going to do for negative error the same data because we want it to go up and down by this amount. And then we click OK. And then you've got your error bars. Now, with standard error, if the error bars do not cross, you have a good chance that the data is statistically different from each other. So this tells the viewer or whoever's reading your paper or watching your presentation that whether your data is statistically equal or if it is statistically different. So in this case, the error bars do not cross. We can assume probably that the data is statistically different from each other. But in order to actually make sure that that's the case, we're going to do a couple statistical tests. Okay, so there's two tests we're going to run here. The first one is called a t-test. The t-test, when you run that, that compares two columns of data. What we're looking for here is the probability that your data, the differences in the data, are either due to chance or because you changed something. Usually when you're doing an experiment, what you want, and I say want loosely because it's science, you shouldn't really have a bias, but if the experiment goes according to your hypothesis, basically you're looking to see if there is a difference between the two columns. So you're going to get something that comes out of these called a p-value. The p-value is the probability that any differences are due to chance. So the lower that number is, the more likely it is that the differences are because you changed something, like you added Kevlar to the helmet. So is there a difference because I added in the amount of force that gets through because I added Kevlar to the helmet? So you want that p-value to be really low. In fact, science, usually we look for a p-value less than 0.05. If the p-value is less than 0.05, that means our data is statistically significantly different between those two columns. And so, again, we're looking for p-values less than 0.05, which that stands for basically 5%. So it's basically like you have 95% confidence that the difference is due because you did something to the data. So how do we do it in Excel? There's definitely ways to do this by hand, and I'll teach you that later. But in Excel, there's a few things you need to do. Number one, for some reason, Excel doesn't have the function built into the standard, so you kind of have to add it to it. So what you do is you go to File, all right? You go down to Options on the bottom of the File menu, and you go to Add-ins. So right down here. And then you go to, on this bottom, it says Manage Excel Add-ins. You click Go. And this needs to be checked, Analysis Toolpack. I already have it in mind, but you'll check it and you'll click OK. When you do that, it should pop up. Where you get it from is the Data tab on the top. So we go click on Data, and over here, all the way on the right, it'll say Data Analysis. So I'm going to click that now. And there's a bunch of different analysis tools that Excel has. So we have ANOVA, which is the second one we're going to do, but the first one we're doing is the t-test. And there's a bunch of different t-tests here. And you're like, oh, which one should I use? The one you should always use is t-test to sample, assuming unequal variances. Variance is how far it is off from each other, how much it varies. Only in math would you have equal variances. But this is science, so you're definitely not you're going to assume you have unequal variance in your data. So I'm going to click OK, t-test to sample assuming unequal variances. And this pops up. It's pretty easy, all right? We click variable 1 range, all right? I'm going to click the arrow again. I'm going to come over here. I'm going to do the two I'm going to compare are the standard helmet and the standard helmet with Kevlar. So I'm going to include the label and go all the way just of my data. Remember, do not ever click in the averages. Then variable 2 is just going to be my second column. Again, include the label. Then what you do is you make sure that this over here, this labels is checked. And you're going to do new worksheet. All right, it's going to basically give you a new sheet on the bottom where this comes out. And the new worksheet, I'm going to call it t-test standard versus Kevlar. All right, and then I click OK. And then what happens is it runs the test pretty quickly. All right, and so we look over here and we get our data. Now, if you look, we've got some nice things. It tells us it's got 2 columns. We've got standard helmet Kevlar, and that's why we included the labels. If you didn't include the labels, it would just be 1 versus 2. And you've got a couple different things that came out here. We can talk about all these later, but what you're really looking for right now is this guy right here, P2 tail. So that's the one you're really interested in, the 2-tailed p-value. If that value is less than 0.05, that means there's a strong statistical difference between the two columns. In this case, it is. So you could write a conclusion. Your conclusion would be, when run through a 2-sample t-test, the force transmitted between, in a standard football helmet and a standard football helmet with Kevlar was statistically different. All right, make sure you spell things right, unlike me. All right. Whatever. All right. So, and then the last thing you're always going to write is parentheses, P less than 0.05. Now, if it wasn't different, if that value was above 0.05, you would change the direction of the less than to be a greater than, and you would say that it was not statistically different. So that's a good conclusion statement to make from the t-test. All right, so let's run it on an ANOVA test. Let me explain to you what that is. So the t-test is good for just comparing two samples, but you can compare all groups to each other with an ANOVA. Sometimes you'll want to do both, and you can talk to me about that. But anyway, the ANOVA, you go back to data, and you go data analysis, and you go up to ANOVA, always single factor. Don't worry about these two factor ones. The first ANOVA single factor. Click OK. Input range, again, I want the labels included. Input range, you just select all your data, all three columns, and click OK. All right, new worksheet. This is going to be ANOVA all samples, and we're going to click OK. Our data will show up. Another very, very quick one. As you can see, the p-value is down here. It's a little bit easier to read in the other one. The p-value here is 2.21, and that e stands for times 10 to this, so it's times 10 to the negative 20th. So you're talking about like 19 zeros before that 2.221. So yes, definitely less than 0.05. And so again, you get the same type of conclusion statement that you can write. When run through, in this case, instead of two sample t-test, we're going to say an ANOVA test, the force transmitted across all variables was significant, statistically different, or you could even say, instead of statistically, maybe a better word, and even for the other one would be significantly different, p less than 0.05. Even though it's 2.21 times 10 to the negative 20th, you still just say p less than 0.05, and that becomes a good conclusion for you. So that's pretty much it. That's how to run, how to make the error bars, and how to run the two most used statistical tests.